Hi, my name's Liam, and this is an exploration robot that I built for my final year school project for Vet Integrated Tech. So to start off, I'll show you the control panel that I made, which is made from using the Python programming language. And if I hit run, I'm prompted with this login screen, so you can choose online mode and put in your network credentials there, and then type the password in, hit enter, and the main control panel comes up here. So there's a fair bit on the screen. On the left, I'll start on the left hand side and just give you a brief overview of what it all does. There's a few things that don't quite work yet, like the battery level, but after that you can see the power usage. So at the moment it's 65, which is roughly 65% of what the battery can offer, which I think I've got a table of what that is equal to in amperes. Power input is for when it's on charge. It's not at the moment. Battery ETA, haven't got that set up yet, but you can adjust the performance, so how much power gets delivered to the motors. You can adjust the controller mode, so you can either choose to use the keyboard or the on-screen buttons, or the steering wheel and foot pedal, which I'll show you in a moment. You can toggle the lights on and off by clicking this button. In the middle you can see the yaw, pitch and rotation of the robot. So what that means is when you're out there driving the robot around, you can see on your screen what its current position is. So there's a little gyroscope in here that sends the data to the control panel. So if I rotate it, you can see it changing on the screen. It's a bit jumpy at the moment, so you can actually jump down to the right hand side and adjust how often it gets updated. So I'll make it 500 millisecond and send that. And now you'll see it's a bit smoother if I'm rotating it. You can see it in more higher FPS, I should say. I rotate it this way, you can see how that changes, and likewise this way. The crane on top of the robot can be adjusted, or the position can be adjusted by changing these numbers here. You can also change the default value by clicking this button, so when the robot starts up, the crane will move to the positions that you put in. Constraints, there's another one. Say if you wanted the crane to only move to a certain position and then stop, for example to stop the forearm from hitting itself, I set up a constraint. You can see on the screen, you can input these numbers here, and when the servo motors hit that number, they'll stop moving. So that's there as just a bit of safety. And crane speed, so if you want to adjust the speed of each individual axis, you can. So if you wanted to pick up something with more accuracy, you could lower the speed, or if you wanted to move quickly and throw something with the gripper, you can increase the speed. So that's a basic explanation as to the control panel I made for it. Now I'll show you how to actually use it and a demonstration of the robot. So this here is the steering wheel, and this is the foot pedal. So you can see on the screen what all the different buttons are used for. There's quite a few. So we'll start by turning on the lights, and we'll see if we can pick up a few of those objects there that you can see on the floor. So I'll take it nice and slow. A bit too fast. So I'll start by trying to pick up a Arduino Mega shield. See how that goes. Let's try the relay instead. There we go. That picked it up fairly easy. It's still a bit difficult to use, but now that it's picked up, you can move it around and drop it somewhere else. And we'll drop it there. So now that you've seen what it does and how it works, I'll show you the details of it and how I built it and some up close photos. So I'll start at the bottom here. This metal chassis is what the robot's built upon, and it's got 4 motors each side to give that sort of 4-wheel drive effect, and they're all spring loaded as well to help it traverse over rocks and things like that. Here's the rotation axis for the crane, so that's driven by this servo motor here. You can sort of see that, and all these other servos here are what controls the crane, and the phone that sits on top of the crane is pretty important. So that acts as a camera to stream to your computer so you can see where you're going, and it's also with the help of this speaker you can talk to people, and you'll through your microphone, and it gets amplified through the speaker, and you can hear people as well through the phone's microphone. So the other use of the phone is the Arduino board connects to the phone's hotspot, so it's all controlled through the internet, through your mobile phone cellular, so you don't have to worry about it going out of range unless you're on Optus. The way it works as far as controlling it from the control panel through the internet to the robot, I have what's called an MQTT server. So MQTT is an internet or a protocol that I use for communicating little bits of data from one robot to another or from your computer. Just a simple and effective way to control things. So I use that and run that at home to control it. The inside of the black box here is where all the components are. You can see a photo on the screen of what it looks like inside. The main brain of the robot is an ESP32 chip that I use to program it and run most of it. So you can either program that in C++ or MicroPython. If you want to have a look at the software I wrote for the Arduino board and for the control panel as well, that's done in Python. You can have a look at my GitHub repositories in the description below. There you'll find all the code that I wrote and some information on how to set it up if you want to use this, if you want to use the same code for your own projects and just change it up a bit. Inside the black box here I've got, as I said, an ESP32. There's also an LCD module, OLED, on the front here, just displays some basic information. You can see the photos on the screen of that. There's some other parts in there like DC voltage regulators, H-bridge motor driver to drive the motors. There's the gyroscope and accelerometer, so that's what gives me the feedback on the screen of what position the robot's in. And there's a few other components, but they're not overly important. There's a little Arduino micro in there as well. So that's a basic overview of what the robot is and how it works. And if you, as I said, if you want to have a look at the code I wrote for it, just have a look at the GitHub repos I made down below. So thanks for watching, hope you enjoyed.